Our next topic is Cauchy Euler differential equation. So far, we have been solving constant coefficient equations. So A2, A1, and A0 were real numbers. Now we are going to do our first variable coefficient equations. Okay. So these can be functions, but we will now we are going to deal now we are going to deal with variable coefficient equations, but not any variable coefficients because the choice here is infinite. We can use any function like sine x, cosine x, tan x, log of x. That will be very difficult to solve. We are only going to do a special case in variable coefficients. And that special case is this equation, exactly this equation. We can change only a, b, c once again. A, B, C are real numbers here. Okay, so we can only what we can choose is A, B, C, which are real numbers, not even power of x. X square y double prime plus xy prime plus y equals 0, that should be same exactly. These constants can be different for different equations. That is what we will call Cauchy Euler. Okay, right. For example, 4x square y double prime minus 3xy prime plus 7y equals 0. Yes, that is Cauchy Euler because we have x square y prime, xy prime, and y. Okay, 4, 3, minus 3, and 7 are okay. X square y double prime plus xy prime plus 10y, that is also okay. So only these kinds of equations we can solve using Cauchy Euler's method. Okay, they are variable coefficient, but a very special case. We cannot solve, let's say, x cube y double prime minus log of x y prime plus y equals 0. No, we cannot solve. It is not Cauchy Euler because first of all, x cube y double prime, we should have x square y double prime, and there's a log of x. This is not Cauchy Euler. We will not be able to solve this with this method. Although it is variable coefficients, it is homogeneous, higher order, yes it is, but we are only after a special case. All right, the method is very simple. What we do is let me start with an example once again. Our example is from exercise 3.6, question number 1. And the question says, solve the given Cauchy Euler. As I said earlier many times, that sometimes the method is not mentioned in the question, so please be vigilant. Cauchy Euler differential equation. Okay. And our equation is x square y double prime minus 2y equals 0. Yes, that is okay to have b 0. Okay, a is 1, b is 0, no y prime term, plus c is minus 2. That is fine. Okay, a is 1, b is 0, and c is minus 2. Okay, we do have a formula to make auxiliary for this directly, but I will like to tell you how does the formula work just in quick steps. But in exam you can write the auxiliary directly. So how do we make the formula for auxiliary? I'll just put it in this brackets because you don't need to do these steps every time in exam. Put y equals x power m. Okay, if y equals x power m, then y prime would be m x power m minus 1, and y double prime would be m minus 1 xm minus 2. And the equation becomes x square m minus 1 xm minus 2 minus 2 times xm equals 0. And that means m minus 1. This x power 2 and m minus 2, they can add m minus 2 plus 2, and they will make x power m and we get m minus 1 minus 2 into x power m, because this one will give x power m. Now, of course, x power m cannot be 0, because if we suppose that x power m is 0, then that gives us a trivial solution y0, which we don't want. We want a non-trivial solution. And that's why we would say m square minus 2 equals 0. And that is our auxiliary. Note that it is different than the constant coefficient case. M square minus 2 would be the auxiliary if there was no x square. But this is m square minus m minus 2, extra term here. So this is very notable. Do not confuse auxiliary of Cauchy Euler with auxiliary of constant coefficients. That is a very important point here. Also, there is a difference after this point. Now m equals, I'll put this thing into, I'll close the bracket here, this one, okay, because this part you don't need to do every time, okay. And now I will write a formula for you: a m square plus b minus a m plus c equals 0, okay. So starting with this equation, you have a equals 1, b equals 0, c equals minus 2. If you use this formula, okay, you can get this auxiliary directly without doing these steps. Let's put the values: a1, b0, and c minus 2. That gives 1 m square b0 minus 1 m plus minus 2. Well, let's directly, why not, minus 2 equals 0, and that makes m square minus m minus 2 equals 0. You see, that's exactly the same auxiliary. Okay, so you have to remember this formula. You have to remember this formula. Okay, for Cauchy Euler equations, which have this variable x square attached to the derivative, okay, you write ABC and use this formula to make the auxiliary equation. You cannot write the auxiliary directly. Okay. Now we write the roots of auxiliary, which are m equals 2n minus 1, and our solution y equals c1 x power 2 plus c2 x power minus 1. Note the very important point here again. It is not e power anymore, because you see, how did we make auxiliary? We started with x power m, not e power mx. Okay? So that's why m goes in power of x, not power of e. Okay? X power 2, because m is x power n. All right. What are the other possibilities here for other roots? Let's write the same set we wrote for constant coefficient equations. First possibility is real and distinct roots. Like we get m equals alpha and beta, and our solution is y equals c1 x power alpha, c2 x power beta. Second possibility is real and repeated roots. That is, we get m equals alpha and alpha. In this case, we write my equals c1 x power alpha, c2 x power alpha log of x. Again, the difference here, if you remember, in constant coefficients, we write x e power. Okay? So we multiply with x here. But in Cauchy Euler, we multiply with log of x here. Where does this log of x come from? Does anybody remember? The reason is exactly the same as it was in constant coefficient equations. What was the reason there? There is a method which we mentioned. Alpha plus minus iota beta. The method's name was reduction of order. Okay? This log of x is from reduction of water. You can check, and I think there are questions in the exercise 3.2 which prove this thing. For complex pair, we have y equals, I'll write down here, it won't be enough space, y equals x power alpha, real part outside, c1 cos of beta log of x, note that it is log of x, not x only, c2 sine of beta log of x. Okay, note that inside the argument of sine cos it is log of x. So if we remember these three things, and we remember that it is power x power, not e power this time, the rest is exactly the same as we did in constant coefficients. So other than these two or three things, that we have a formula to write the auxiliary, and we have different style of writing the solution. Now we use x power, and for repetition we use log of x, and inside the argument of sine cos we use log of x. The style overall is almost the same as it was in constant coefficients. Okay, let's do a couple of examples here. For example, this is question number 6. It is x square y double prime 5xy prime 3y equals 0, a equals 1, b equals 5, c equals 3, am square b minus am plus c equals 0. That gives m square. 5 minus 1 is 4, and plus 3 equals 0. Our roots are m equals minus 1 and minus 3, which is real and distinct like alpha and beta. Okay, minus 1 and minus 3. So y equals c1 x power minus 1, c2 x power. Let's do one more. 4 x square y double prime plus 17y equals 0. A is 4, b is 0, c is 17. So am square b minus am, b minus am plus c equals 0. 4m square plus 0, so this will become minus 4. M plus 17 equals 0. Roots of the equation are 1 by 2 plus minus 2 iota, complex. So y equals x power half into c1 cos of 2 log of x plus c2 sine of 2 log of x. Okay. Find the charge Q of t on a capacitor in an LRC. There are three components: series circuit when L is given, H is given, and C is given. E of t and all the variables are defined. Equation is, in this case, if you remember, I told you that in application problems for linear first order, I will not give you the equation, but in this case, I will give you the equation, okay, in the question. R dq by dt 1 over cq equals E of t. What is the data given? Data is L equals 0.25 Henry, and next is R. R is 10 ohms. Next is C, 0.001 farad. What else do we have? We have E of t equals 0, so it's a homogeneous equation. We have Q of 0 equals Q naught. That is our first initial condition. We need two of them because our equation is second order. And we are also given I of 0 equals 0. Remember that in these problems, I equals dq by dt or q prime. Okay, right. So we have all the data we need. we just put the values into the equation and it becomes 0.25 q double prime plus 10 q prime plus 1 over 0.01 q equals 0. Note that it's a constant coefficient equation and homogeneous, so we can write the auxiliary directly. Right, note that it is a constant coefficient. All these coefficients are constant and it is a homogeneous, so all we need is just auxiliary and we can find the solution. Plus 0.001 equals 0. So you can use your calculator to find the roots of this equation. Roots are minus 20 plus minus 60 iota, complex pair. That means our solution q of t, t is our independent variable, q is our dependent variable, minus 20t into c1 cos of 60t plus c2 sine of 60t. Right, our conditions are q of 0 equals q naught, where q naught is a constant, non-constant. We will treat this as a non-constant. We have done this in first order equations case. When we put t equals 0, so this becomes q equals 0, and this side e power 0 c1 cos of 0 plus c2 sine of 0. And that means this one is q naught. It is given that q of 0 is q naught. E power 0 will become 1, cos 0 will become 1, and this will go 0. So C1 is the only thing which is surviving. That gives us value of 1 constant. Similarly, we put q prime, I prime of 0, I of 0 equals 0. As I said, I is basically dq by dt. Okay, I equals dq by dt, or q prime you can say. This means the condition is actually q prime of 0 equals 0. Now first we have to find derivative of q to put this, to use this condition. Okay, I'll leave this step for you. That's very easy step. Find the derivative of the q and then put this condition to find c2. Okay? We already have c1, and that will tell you that c2 is 1 by 3 q naught. Okay, after solving the whole thing, you will find out that c2 is 1 by 3 q naught. That will complete our solution. Okay, q of t equals e power minus 20t. C1 is q naught, so q naught cos of 60t plus 1 by 3 q naught sine of 60t. You can take q naught common if you would like, and that completes the solution.